Dear students, in this video I will discuss about the ray diagrams for coherent sources. So first I will explain about the coherent sources. The sources which produce the waves which have constant phase difference or path difference are known as coherent sources. And we require the coherent sources or coherent waves for the phenomena of interference. This is a necessary condition. Coherent waves are the necessary condition for the phenomena of interference. We have 5 methods for production of coherent sources, and first method in which we can produce the coherent sources, that is Young's double slit experiment. In this video we only draw the ray diagrams of production of coherent sources. Suppose this is a monochromatic source. This is a monochromatic source, and we know these are the wavefronts, and if we have 2 pinhole in front of the wavefront, then these pinhole are illuminated by these wavefront and produce the secondary wavelets. These are the secondary wavelets, and similarly by this pinhole, these are secondary wavelets, and these 2 pinholes behaves like the sources S1 and S2. And if these pinhole behave like the sources, we can say that S1 and S2 are coherent sources. The phase difference by the wavelets produced by these 2 pinholes are always constant, or we can say the path difference remains constant. So this is first method for production of coherent sources. And now second method. Second method is Liod's single mirror method. Single mirror method. In this method we use a single mirror. Suppose this is a single mirror, this is a source, and it should be a monochromatic source. This is incident light ray. Suppose this is refracted light ray. First incident ray, first reflected ray of this incident ray, and we can extend in reverse direction. Suppose this is second incident ray, this is second incident ray, and it should be second reflected ray, and it should be the image of this object, and object and this image of the source both should be the coherent to each other. So source S and S dash both are coherent to each other, and the rays produced by S and S dash are having constant phase difference or constant path difference. So this is second method of production of coherent sources. Now we will move towards the third method of production of coherent sources, and third method is Liod's double mirror method. Now I erase it. Liod's double mirror method. And in this method we use 2 mirrors which are inclined at an angle this is mirror M2 and this is mirror M1. This is a source and it should be a monochromatic source. Incident light ray, suppose this is first incident light ray, this is reflected, we can represent it by one dash, we can extend it in reverse direction. Second light ray is incident on the joint of both the mirror. This is the junction point of mirror M1 and M2. This is second incident ray, and second incident ray will be reflected by mirror M1 and mirror M2 both, as it is a junction point. Here effect of both mirrors are available. So reflection by one mirror, this is one reflected ray, this is second ray, and this is 2 dash, means reflected ray of this incident ray, and it is reflected by one mirror. And due to the reflection of second mirror at this point, suppose this is reflected ray by second mirror, and again we can extend in reverse direction, and suppose this is third incident ray, and it should be third reflected ray, and S1 and S2 both are images of this source S. It means S1 and S2 behaves like the coherent sources. The waves which are produced by these two sources remain coherent, and the phase difference by the S1 and S2 are always constant, or we can say path difference remains constant. So S1 and S2 both are coherent sources, and the intensity of the waves which are emitted by these two sources remain same, as both are the images of a source. In large single mirror method, we have two coherent sources. One is original source and another is image of the original source. So intensity of these two sources are slightly different to each other, but in this method intensity of these two sources are always remain same. So interference which is produced by Liod's double mirror method is better than the interference which are produced by the coherent waves of Liod's single mirror method. That's why Liod's production of coherent sources by Liod's double mirror method is far better than the production of coherent sources by Liod's single mirror method. So this is third method of production of coherent sources. Now we will move towards the fourth method of production of coherent sources. Fourth method of coherent sources is Freshnel's biprism experiment. Freshnel's biprism experiment. This is a biprism, and this angle of the biprism is 179 degree. This is an isosceles triangle. So these two angles are equal to each other, and it should be half degree, or we can say 30 minutes. Again it should be half degree or 30 minutes. This is a monochromatic source. One light ray which is incident at this point is passed through just like this, and suppose this is first incident ray, and this incident ray should propagate and pass through this point. This is first refracted ray. And similarly, we can take second incident ray, and it should be passed through this point, second refracted ray. Similarly, we can take and we can extend these refracted ray in reverse direction. And similarly, we can take third incident ray. This is third incident ray, and it is refracted just like this. It should be third refracted ray, and we can extend in reverse direction. This is intersection, and it should be a virtual source, virtual image of this object source. And similarly, we can take fourth incident ray, and it is again refracted in this direction. 4 dash represent the refracted light of this ray, and we can extend. It should be the image, second image of this object, and these two S1, S2 are virtual images of this source S and behaves like the coherent sources. S1 and S2 both are coherent sources. Both are coherent sources, and these coherent sources produce the coherent waves which are producing the interference phenomena. This is fourth method, and in general we use this method for production of coherent sources in our physics lab. So this is fourth method, and now we will use last method of production of coherent sources. This is fifth method. Fifth method is Michaelson interferometer. This is fifth method. We use only ray diagram for this experiment, for this method interferometer. Suppose this is a source, and it should be a monochromatic source S, incident light ray, incident on a partially silvered plate. This is a partially silvered plate inclined at 45 degree, and this partially silvered plate reflects 50% light in this direction, ray 1, and refract 50% light in this direction. So this partially silver plate, some part of the light is reflected by this partially silver plate, and some part is refracted by this partially silver plate, and ray 1 and ray 2 are the division of this incident ray. Now we put the mirror perpendicular to this ray, mirror M1, and similarly mirror M2, and the distance L, it is again distance L, and due to this mirror M1 the ray is reflect back, and similarly from M2 the ray is reflect back and intersect at this point, superimpose at this point, and we can see the superposition of both the waves, and we can see the interference phenomena at this point by the help of this telescope. So at this point the rays are coming from mirror M2 and mirror M1. So for this point mirror M1 and M2 behave like the coherent sources. So in this method coherent sources are M1 and M2, and these are 5 methods by which we can produce the coherent sources. We can produce the coherent waves, and any method we can use for the phenomena of interference phenomena. So thank you, and for any doubt you can ask question in comment box. Thank you.